what are the lessons that we learned from the questions A, B, and C? Well, one thing that we want to keep in mind is between the three different questions, the sample size, the effect size did not change very much. So all the sample size, effect sizes, keep saying sample size, but the effect sizes were relatively the same, right? So here's the one for the first question, and that was approximately what the effect size, approximately 0.004 or something in that range. Maybe 0.005 for another question. Yeah, a little different, 0.005. Okay, but somewhere in there. So that didn't change much. So that's one thing we do notice. Well, what else did we notice? The sample sizes were increasing. So the sample sizes are increased, and the result was that the p-value decreased. And why is that? Well, what's happening is the effect size, again, is staying relatively the same. It's not changing that much. But we also notice, remember, we've calculated the standard deviation, and here are the different sample sizes. This was for a sample size for the very first one of 450. And when I calculate the standard deviation here for this one, it turned out to be 0.02357, which we did earlier. The second one, this was a sample size of 15,532, and the standard deviation for this one approximately was 0.004, and the last one for n equals 45,532, standard deviation had gone down to 0.002. So half, little less than half of this one. So I'm running out of room right here. And you can see that in this horizontal axis. Here's 0.5, here's 0.524, 5.47, 5. And when we looked at where the p-hat value landed, each one was very close to 0.5, right? So it's just a tiny, tiny, tiny difference, which we can't even note because, again, the p-hat values, sorry, the p-hat were nearly the same. So they were just about the same and very close to 0.5. And look at this. This is 3 standard deviations. There's 1, 2, 3 standard deviations. On either side, this is 1, 2, 3 standard deviations, 1, 2, 3 standard deviations. And if I look up the scale, here's 0.4, 0.488, 0.512. Where is that here? Well, this is 0.47, so 0.45, so 0.48 somewhere here. I'm going to be rough. This is rough, but somewhere in there is 0.48. What about this one? Where is it at? Well, this is 0.494, 0.506, so 0.494, I'm going to guess something like that. Very tight. So really, this curve, they all look about the same right now, but when you put it to scale, all of a sudden, this has shrunk. It goes, this range goes from here to here. This range goes from here to here. So the curve is just shrinking. So one thing that we want to take out of it, a lesson learned, is if you increase the sample size enough, you will find any result to be statistically significant, since there will always be some slight difference between our assumed null and statistic. But what we must do is determine if that difference, the effect size, is of any practical importance or practical significance, which we'll look at next. So the lesson again, as the sample size goes up, the p-value will decrease. Okay? And again, the reason being is, I'm going to draw one more picture, is that this value, this null value, is assumed to be correct. There's probably a good reason why we chose this. But no matter what, most likely is an estimate of some sort. And then there's the actual. So I'm going to draw another one. I'm going to separate a little more, but these are typically very close together. So I'm exaggerating how far apart they probably are. But there's probably a correct parameter. I'm using P right now because we're using population proportions. So I'll call this A for actual, and this is a null value. So if that's the case, if there is a slight difference, then that's what you're seeing eventually. If the sample size goes up, we're going to be able to detect that small difference. And that's what's happening on the third try. We shrunk standard deviation so much that all of a sudden we were able to detect that there might be a difference. So there was a difference between our p-hat value and the population mean, even though that difference is tiny.